I will kick off. I'm Anna. I am representing the West Midlands branch of the Academic Health Science Network, so the organisation that has facilitated this event today. So welcome. This is a session on consumables. As I said, we've got some brilliant innovators lined up. Just a reminder that this session is recorded, so if you don't want to be on the recording, do keep your camera off. Be aware of that. We'd really appreciate it if you could put your questions in the Q&A function in the top of the chat. Just makes it a little bit easier to facilitate some of those questions. And again, these sessions are designed to help encourage networking and collaboration. So do pop your name and contact details in the chat if you want to be able to allow for some of those things to happen. So just for the schedule for today is that we've got quite a number of innovators to work through. We've got about 10 minutes for a presentation. I will give them 1 minute warning, and then we'll have a little bit of flex. We've got a little bit of time, about 5 minutes for questions after that. So again, pop the questions in the Q&A. And if I do miss them in one or the other, please then just pop your hand up within that question time. But first off, we have got Luke Rawlinson from SageTech, and I will hand over to you, Luke, to introduce yourself.
Lovely, thank you, Anna. So good afternoon, everybody, and I hope everybody had a nice lunch. I'm going to be presenting around the anaesthetic gases and as waste, and the solution that SageTech has developed, and really share some experiences from the UK market and some case study work. So hopefully it will be a good session for everybody. So let me share my screen. Can you see the presentation, Anna?
Yeah, that's perfect. It's great. Thank you.
Lovely. Thank you. So really starting off with just a quick introduction as to the problem of waste anaesthetic gases. In the UK, we see that these anaesthetic gases are a priority for the NHS under the Scope 1, which is directly controlled emissions in the NHS carbon footprint plan. And I was just in the Imperial Trust yesterday speaking with the anaesthetic team, and one of the key themes that came out of that discussion was who knew what the size of the problem was, with over 95% of these gases being emitted. So the patients are breathing these gases off after they've been delivered to put the patient to sleep, and these are taken by the gas scavenging system in the hospital and emitted into the atmosphere. And they have a significant carbon footprint, with the main gas that's in use today being sevoflurane, and this has an impact of over 500 times that of carbon dioxide when you compare that in GWP 20. And what that basically means is in the UK alone, there's over 100,000 tons of CO2 equivalent emissions being released each year from these volatile agents. And we know that the government is committed to reducing these emissions by 80% by 2028-32. So time is certainly ticking. In terms of SageTech Medical, we are an innovative startup business based down in Devon, and we've developed a solution to prevent the release of these gases by capturing them and then recycling them back into reusable anaesthetic agent. So we're also conserving the raw materials used to produce these agents in the first place. And the system and solution that's been developed has really focused on three main themes, which is safety, sustainability, and ease of use and adoption. And what I'll share with you now is some of the feedback that we've had from the UK hospitals in our early launch at the beginning of this year. So we've been on a bit of a journey. We started in 2015 by an anaesthetic doctor based down in the southwest with the simple mission to prevent the pollution from these gases. And as I said, we've now got to a point where we've got the UK CA mark to enable sales into the UK at the early part of this year. And we've had a few other milestones that we've reached. One of the key ones being that we've demonstrated compatibility with the anaesthetic machines that we need to connect to. So we connect to the exhaust of the anaesthetic machine to collect these waste gases. And these gases are hazardous waste, and they need to be safely captured and managed effectively. And we've also recently worked with Draeger in the UK to enable our solution to be accessible via the NHS supply chain framework. So that's that. In terms of case studies, there's two main published studies that have been, these are independent studies done by UK hospitals. The first one was done by Guy's and St Thomas's Hospital, and this was an in vitro study which looked at the performance of our solution with a full anaesthetic circuit, but without a patient, because we know that the patient is a significant variable. So the key output of that study was that the capture technology achieved 94.8% of capture from what was originally delivered. And then the second study was done by Newcastle upon Tyne NHS Trust. And this was an in vivo study, so with patients, but with no change in the clinical practice. And that showed 51% of the volatile delivered was captured. And this is over double the capture performance of any nearest competitor in published studies. And there is further research underway looking at how do we support clinicians with good volatile anaesthetic hygiene practice. Another study that may be of interest is in the UK, there is obviously a very important drive to remove desflurane, which is one of the three gases used to put patients to sleep. Now, desflurane has a significant and the highest impact in terms of carbon footprint, and there is certainly a drive to ban and get rid of the use of desflurane where it's not required. And that actually leaves us with a bit of a problem, which is the unspent desflurane in the vaporizers of the anaesthetic machine. So Manchester developed a protocol with our technology to safely capture and prevent the release of these gases from desflurane, and again achieved a very high capture rate of 94%. And what this enables them to do is provide a replicable approach across the 42 ICSs in England to adopt essentially a plug and play solution to solve this problem. And once that has been done in their region, they will then be deploying these capture machines in clinical practice for the capture of sevoflurane. And the key takeaway for me from that was the study concluded that the technology is an efficient means of capturing the desflurane using high flow methodology, so for speed. And this was led by Dr. Clive Shelton, who's a consultant anaesthetist and the sustainability lead at the Wythenshawe Hospital as part of the Manchester Trust. And as you can see here, this is just some of his comments around the project work that's been done, certainly focusing on the need to consider how best to deal with the problem in an environmental way, and that this is using the SageTech solution does offer a real solution to the problem. And I think the funding that they've achieved from this does then allow them to roll that out into the Trust for Clinical Practice after that. Another case study, so with there was the first UK competitive NHS public tender that was run by Hull University Trust for gas capture technology, and the technology is estimated to save the trust 780 tonnes of carbon emissions each year when implemented across all the theatres. And I think the important bit I want to get across from this and share in the next slide briefly is the selection criteria for that tender was heavily focused on quality. Price was certainly a key component of that, but you'll see in a second the focus on the quality, and that really included considerations around safety and performance and ease of use and adoption. Now, with Hull, the anaesthetic gases for them made up 17% of the trust scope 1 and 2 footprint. So it's not an insignificant amount, or that the gas capture system is solving the problem of. And they'd already made significant progress in the last 18 months by stopping the use of desflurane and reductions in Entonox usage. And it was really them then looking at the next step as to how they can further reduce emissions. So I won't go through all of this, but this is just a flavour for the selection criteria. So there were mandatory requirements for selection, simple things such as ensuring that the anaesthetic machine can continue in the event of a failure of the capture equipment. So this is all about risk mitigation and ensuring that the safety systems of the anaesthetic machine remain functional. But the key bit I was trying to get across here was that the weighting on the tender criteria and how it was measured was heavily focused on quality, and 75% of the criteria was around quality. The next one is a case study from the Bupa healthcare system. So the Bupa group have the Bupa Cromwell Hospital in London, and we were fortunate enough to be selected to participate in Bupa's global eco-disruptive program. And this was to identify innovative technology and startups specifically to help prevent pollution from healthcare. And we were a finalist in that program, and I'm really excited to say that we've just signed a 5-year contract with Bupa for the theatre-wide adoption at the Cromwell, and that is estimated to prevent 805 tonnes of carbon emissions during that term. And the feedback from the staff on the use of the equipment following the evaluation was really positive as well. And the sustainability director from Bupa, is driving the agenda strategically to make Bupa a more greener healthcare provider.
Probably just final minute there, Clive.
Thank you.
Sorry, Luke.
Yeah, that's all right. Just coming to the end, so that's good. And this is just a bit of a flavour for the feedback that we've received, not just from Bupa, but from evaluations that we've been conducting in the UK. And really, it answers the question as to what is the safety profile of the solution, ease of use, and the sustainability and performance. So we've got some really good feedback from the UK hospital studies and pilots that we've been running. So I was asked to put together a question to raise to the group. So this is it. So when and how can the NHS change to a new paradigm of funding environmental solutions when it actually costs more than the current practice? So with anaesthetic gases as an example, it doesn't really cost anything to pump these gases out into the atmosphere. But obviously any solution adopted by healthcare will come at a cost. And that's it from me. So thank you very much. And I'll happily take any questions.
Thank you. That was really good. Have we got any questions from anyone in the audience? Moment. So I was really interested to see how your I think you talked about how you're doing a piece of work around good anaesthetic hygiene practice. Are you able to give kind of a really brief sort of overview of what that might look like?
Absolutely. So off the back of the study works already done by Guy's and St Thomas's and Newcastle, the protocol has been added to by a trust up in Scotland that are investigating how can we maximise the amount of gas being directed towards the capture system. So it's looking at simple practice, good practices that the anaesthetists can do and the anaesthetic team can do to contain the gases inside of the circuit so that we're capturing and maximising capture for then future recycling. So that will come out soon.
Lovely. That's really interesting. So any further questions? I can't see any in the Q&A, so I think that leads us nicely on to our next speaker, Daniel Coole, who is from Surgical Holdings. So I'll hand over to you, Daniel.
Hi, good afternoon, everyone. Thanks to Pete, Anna, and the team for allowing me to present. I'll just attempt to share my screen, which hopefully you can then see. Okay, so we're Surgical Holdings, and I'm just going to run through a bit about what we do in relation to Smart Repair, which is our repair and refurbishment service for medical devices. So a very brief introduction about us. We're a manufacturer, repairer and distributor of surgical instruments. Our repair and refurbishment covers surgical instruments, lap instruments, electrosurgery, rigid endoscopes and power tools. We were established 35 years ago, so this year we have our anniversary, based in Southend. We employ 55 people, which is roughly a sort of 50-50 split of technicians and admin, quality, sales, and all those other, obviously everybody else important in the business. And we're supplying UK hospitals and also exporting those services around the world. So why maintain instrumentation and medical devices generally? Well, this is an image of exactly why you need to do that from a clinical perspective. This is a nicely gunked up Ronja. So apologies, this is just after lunch if anyone's just had their lunch, but this is what we're faced with sometimes when we take apart devices, and this is a device that hasn't been maintained regularly. Obviously, this is a bad thing for both the patient and of course the surgeon who's trying to use the device. So regular maintenance will of course mean that this doesn't occur. And surgical instrument repair or medical device repair is sustainability in action. In my opinion, it's a reward of that. As we're looking to move from a linear economy model to a circular economy model, of course, the repair element of medical devices fits nicely into the circular economy model. And this is the sort of thing that we do, what it looks like. Basically, it's reworking, rewelding, refinishing, polishing, using a few different skills that we have in-house. So this is the before and after, typically on an orthopedic mallet. So we can take something that might be like 20, 30 years old, completely refinish it and turn it into virtually new. And I'll just I'm going to run through an example of how we've done that with a hospital and what that looks like. So this was a hospital that we work with in East Anglia. And they had a scenario where they were going to buy a load of new instruments. So there's over nearly 140 sets here from various different surgical disciplines, and we were able to demonstrate what we could achieve through refurbishment of these devices as opposed to buying new. And they were very happy with what we were able to achieve. So obviously, typically that looks like the image previously, the before and after. So they actually went with us on this, and they saved over £90,000. And this was a process we went through with them over a sort of 18-month period, a managed service, working with them when they were able to free up sets, basically working with them to upcycle their sets, replacing instrumentation that might have been broken, but generally aiming to refurbish and repair all of their kit. Obviously increasing patient safety as well, and also improving the clinicians' confidence in their products. This was a comment from another site we work with, who remarked that the devices themselves were brought back to as new standard, and other comments we've had is that the surgeons get a real buzz out of feeling they've got new kit as well that's obviously been refurbished. So we're utilising traditional skills. This service that we offer allows us to employ more people, training more people, employing apprentices. So there's a number of different things we do in the process here. So there's a few of them pictured here, which are traditional engineering, things like milling, working with lathes, turning, but also welding, polishing. There's so many different aspects to this. So it's a great thing for developing careers and opportunities in our local area. And of course, it also helps to reduce CO2 use across the world. or creation of CO2. So this is a graphic we produced. When we first started offering this service, we did some work with Anglia Ruskin University, and they worked with us to produce some of this information. Overall, as a summary, we worked out that refurbishing devices reduces the actual CO2 consumption by about 50%. Obviously, you're taking away all these factors such as the mining, the shipping, the manufacturing, and just concentrating on refinishing, using the device, and then obviously the transport of that. So that's a massive saving. One interesting fact that came up with out of that was that the energy required to produce, I think, over 5,000 scissors in terms of refurbishing them rather than actually producing new could power a domestic house for a whole year, which is obviously a considerable saving in that respect. So one thing, obviously, we do the physical element of the repair work, but we also got our own software, our own database that we own and therefore are able to produce different data sets working with our customers. So our customers can log into, and hospitals can log into this Surgifix portal. It allows them to input all of their devices they want repaired or refurbished. We then get all that information in real time. We can arrange collections of these devices. But probably most importantly, the output of this is the data that comes out of it. So it then allows us to analyse which devices are being repaired the most. Oh, sorry, I don't want to do that. That then allows us to come up with just some basic analytics, which you can then see which devices are repaired the most. So in this case, it's scissors, scalpel handles, retractors, just the typical devices. And then we feed that back and create training programs for our hospitals, if they wish us to do that, to allow them to reduce the damage that they're incurring on those devices. So obviously we go to hospital theatres, sterile services, and work with our customers. In this instance, we're talking about rigid endoscopes, which have thin glass rods inside them and are very easily damaged. So by helping identifying things that are regularly damaged, different types of scopes, we can then work with them to resolve that issue. So a big important point of this work for me is that the quality of the repair. So we aim to offer the highest level of quality on the market from an instrument manufacturer's perspective. An instrument maker, repair quality should equal optimum clinical performance. So in my opinion, so this is an example of the sort of poor quality of repairs sometimes we see in the marketplace, which won't do the job for the patient or for the clinician. So this is what, in this instance, that device should look like. And just to prove that it does work, we sold a reusable needle holder back in 2004. That came in for repair recently from a hospital we work with, and we were able to completely refurbish this and put it back to as good as new. So you know, this is a relatively low-cost device that we've now refurbished and is going to be good to go for another 20 years, which is obviously fantastic from a sustainability perspective. In summary, and so just to talk through the areas, obviously, that I've discussed, that obviously without maintenance of the devices, there's a big risk for the patients and indeed the surgeons who are trying to use these devices. The repair of these devices has allowed us to create more jobs, utilising our skills that were traditional instrument maker skills, really, that we've repositioned for the benefit of sustainability. There's a huge cost benefit of this. And as I mentioned, any repairs that are carried out should not be at the detriment of the patient. We should be retaining and working towards OEM standards or working to OEM standards. Obviously, the refurbishment element means a big reduction in CO2 use for refurbishment versus buying new. And working with data, we can obviously, we're aiming to reduce the CO2 and improve the sustainability element of the devices that we're selling. But we can reduce this further by identifying and looking at trends where things are damaged and having to be repaired, and then reducing this further. Just simple things like oiling devices regularly is a quick win for that sort of stuff. Yeah, that's me. So just stop sharing the screen. So yeah, if you have any questions, please ask. I'll just stop sharing that. So there we go. Thank you, Anna.
That was really great, Daniel. I think there were a couple of things that sort of stood out to me. Just and some of those co-benefits, I think, of sustainability. So with the Academic Health Science Network, we're always looking at how we can help with sort of increasing workforce and capacity within our regions. And I think you highlighted there the sort of the training scheme that you've got, or that you're able to provide, and the apprenticeships that you're able to provide, which I think is something that's really encouraging, and sort of the creation of jobs within your economy. And then also something, and it's a fairly obvious thing, but just by reusing, we're able to reduce that sort of the carbon footprint of the manufacturer, the transport, all of that thing, and sort of keep things more local to home. I don't know if anyone else had any questions.
If there isn't, Anna, I could make a comment just around the educational thing, which, you know, is a bit of a passion in that. I think moving, when you're training as an instrument manufacturing technician to make instrumentation generally, you have a long presentation, a long apprenticeship to allow you to get those skills. But if you're training to repair things, you can become very useful quickly to a business, because you can train on certain elements. So it is something that lends itself to employing people and train them up and making them useful in an organisation. So there's a lot of value there. I think that's sort of from the social value perspective for the sustainability.
I think it's just such a lot of cross benefits there, aren't there, that can be brought in, which I think is really great to see. Like a really good comment here from Minna. It would be really useful for every trust to have a repairs department where all staff can bring all kinds of things to repair from home, even from home too, maybe, which I think does indeed sound like
good idea. Yeah.
I think that indeed, really good idea, and something maybe one day in the future we will get to see something like that. I think I guess alongside that is sort of the considerable cost savings. So you've sort of got a whole package there, haven't you? A carbon, a cost savings, a social value element of that.
Yeah, there is. I mean, there is a huge cost saving. You have to consider that, of course, the devices need to be collected from the hospitals to be repaired, and there is obviously the factor there of collecting them, and these are all reprocessable devices. So versus potential single use, you've got that. You're weighing up that, of course, but there's obviously, if you can prevent disposing of something, and you can do it in the UK potentially, or locally in Europe, even it's got to be better than throwing it away and having to make a new one. Obviously, clinically, there are certain devices that we would always say should be single use, and that that's just for patient safety. As I say, patient safety shouldn't be risked to try and obviously just repair something. There's got to be a level of quality that we're able to replicate and produce.
And are you a fairly local organisation, or do you work nationally?
Yeah, we're all across the country. Yeah, so we've got a sales team that is throughout UK up to Scotland. So yeah, and to be honest, the repair element of it, we're doing a lot more from an export perspective as well. We're getting we've got export customers for things like scope repairs for the sort of higher value stuff from recently, like Qatar, Saudi. So lots of different people are from lots of different countries are looking at this now and trying to save money, and obviously look, to save, of course, wasting materials and energy.
Really good, thank you.
Great.
Thank you for that, Daniel.
No
We
problem,
will
thank you.
move on to our next speaker. So Paul Broadberry from Vanguard, and I will hand over to you.
Thank you very much. Okay, right, let me just see if I can share my screen. Okay, I'm hoping you can see that okay. Okay, so thank you very much to Pete and to yourself, Anna, for allowing us some time on today's agenda. My name is Paul Broadberry. I work for Vanguard. We are a medical remanufacturer of some of the single-use devices Dan was just alluding to. So the objective over the next few minutes is to give you a bit of an insight into single-use medical device remanufacturing, which is what we do. We are a third-party remanufacturer, so we collect devices from a number of OEMs and safely remanufacture those. And to give you a bit more insight into the program. In terms of program, what it means to a hospital, there are two very clear facets, if you like, of the process. One is the harvesting and collecting of the used devices, and the other is actually reusing remanufactured devices. I'm going to start with a case study. Leeds General Infirmary, the cath labs, which is a derivative of the cardiology department, have been doing both. And you can see some of the metrics that are produced as a result of that. So on the collections, and this is in 2021 for all things, despite all things COVID, they diverted or sent to us to be repurposed 75 kilos of electrophysiology catheters. We pay a nominal amount for each device that we collect and accept. And they earned £22,923 for that, which is not a small number for stuff you'd just be chucking away ordinarily. So that's on the collection side. On the reuse side, they used 604 devices and saved an estimated £76,610 versus using a new device. We have a very detailed life cycle analysis, the sensitivity analysis of which has been performed by the University of Brighton. So the brightest and best have looked at that, which is good. And from that, we can cite a 50.4% reduction in greenhouse gas emissions by using a remanufactured device versus a new, and therefore we can then equate that out to over half a ton of CO2 was avoided being emitted by using those devices. So really strong case study. Just not to be outdone, just along the road in Leeds is St James's Hospital. They are also using a different portfolio of remanufactured devices that we can collect and then resupply and from their theatres. And you can see the numbers that they delivered, and that was just in half a year during 21. We have actually now have some hospitals that are producing those numbers in 1 quarter as the usage of remanufactured devices ramps up. Bit of context here. We don't need to dwell on this at all. Everybody on this call is very aware that there's a bit of an environmental issue out there, and that the NHS is doing a great deal to try and address those issues, with 590,000 tonnes of waste being produced and between 4 to 5.4% of the UK's greenhouse gases. Now, what I'm here to say very clearly is that what we do is not going to solve those problems, but what it is a step in the right direction, and actually we fit into the Centre for Sustainable Healthcare's principles of delivering healthcare more sustainably, and we come into the 4th bucket, which is a low carbon alternative. But as a step in the right direction, we also have the support of NHS England, who've produced their own how-to guide, helping trusts establish their own remanufacturing programme and talking them through how to do that. We also have the support of the Greener NHS team, and remanufacturing gets or reprocessing as a nomenclature states is cited in the delivering net zero report, and can help trusts and the NHS generally help to start to decarbonise the scope 3 emissions. And our devices, speaking of supply chain, our devices are fully available via NHS supply chain, so you have a bona fide route to market should hospitals wish to purchase remanufactured devices. Importantly, we also have the support of the clinical associations, and in particular the Royal Colleges, who have cited using a remanufactured, in this case, harmonic scalpel, is something that a hospital should be looking to do, who's looking to reduce their environmental impact. And it's mentioned in the Intercollegiate Green Theatre checklist as a recommendation. So it's great to have that support as well. So what is it we do? So essentially, we take some previously deemed single-use medical devices that you ordinarily throw away and turn that back into a new single-use device. So if you let's take a harmonic scalpel as an example, the original ones that these are made, which is used in laparoscopy cases. The original is made in Mexico using valuable earthly resources. It's shipped through the supply chain to a hospital near you where it's used for a few minutes at a time and then thrown away. These devices are expensive and complicated. So all we're saying as a remanufacturer is please don't throw it away, give it to us. We then send it through our collection process to our plant where it gets an initial clean. It then gets a laser mark. On that laser mark goes information from the original device plus where the device has come from. So we have full traceability. The device then goes through a thorough, in fact, gets taken apart and then goes through a thorough cleaning and decontamination process. It then gets put back together again and then gets tested to the nth degree so that the actual functionality of the device meets that of the predicate original device. It's then sterilized, also packaged and then sterilized to industry standards and goes into a pool of devices that are CE marked and soon to be CA marked, ready for any hospital in Europe to purchase. The CE mark stipulates the number of turns that device can have. So for our harmonic scalpel, the CE mark enables or has been proven to allow 2 extra turns. So use it once as an original and then two as a remanufactured single-use device. For some of the EP catheters, is up to 4 times. So it's adding, whilst not fully circular, a degree of circularity to the life cycle of that very valuable and very good single-use device. So that's what we do, helping to conserve said valuable planetary resources by keeping costs low with no compromise whatsoever on safety or performance, which is a key point. So again, just to touch on I guess some of the benefits to a hospital of adopting a remanufacturing program. We've talked a bit about the savings product. A remanufactured version of a new one from Vanguard is thereabouts half the price of a new product. So there are some inherent savings for adopting the scheme. We talked about the payment for collections. There is a small waste saving to be generated, although again, it's such a tiny dent on that 590,000 tons. It's not really sort of registering on the scale, to be perfectly honest. But the supply chain resiliency, which is the 4th point there, is actually becoming and has become a more important element to the program. If there's a significant issue with supply or the manufacture of a new device, it may be we have a supply of the remanufactured versions, which will help to keep some of the services going, albeit we do run out of products ultimately if there aren't any new ones being used, but it can provide a buffer to help keep services going. And then the environmental side of things, again, we've got LCAs and detailed LCAs therein of the 2 key portfolios, which cite the benefits from an environmental perspective for abiotic resource use as well as for the greenhouse gas emission reductions. And then the 3rd point, again, the quality assurance is vital. In the hands of a physician, they need to know if they're using a remanufactured device that it's clean, it's sterile, and it works exactly the same way as the predicate device. So all of our processes are geared to deliver exactly that, and all of the processes and checks of our auditors are geared to ensure that we do that as well. Maybe relatively new to the UK, but remanufacturing, as we do it, has been going in other parts of the world for over 25 years. If you go to the US or Germany, for example, two geographies there that have fully embraced and embedded remanufacturing into their standard operating procedures, and they've been fully regulated in those locations for a large proportion of those 25 years as well. And in Canada, Israel, Japan, so there are other countries that are really bringing this through to the fore, and there's parts of Europe that we're now rapidly expanding into as well. Vanguard is a company we're Germany based, where again this is what we do is prevalent. We have over 1,000 customers, 2.8 million devices have been safely remanufactured and gone on to be reused, and that number goes up obviously each and every day. All the main German general purchasing organisations for the hospitals use us as part of their savings work streams each year. And as mentioned, we're rapidly expanding into other parts of Europe. In terms of the UK, the MHRA produced guidelines in 2016 that really provided a platform from which we could start to build the provision in the UK, and we now have 75 UK hospitals on board, with a host more looking to join the family, which is great. In terms of what
final minute, sorry.
Oh, okay. In terms of what remanufacturing delivers globally, there's an association called the AMDR, and they can, if you'd like to go to their website, there's some massive numbers in there. Our job is obviously to proportionally replicate that in the UK. Some more on the process here. You can see how we take the devices apart. Obviously, it's critical that these devices are clean, sterile, and the testing to make sure they work is very detailed, particularly around the material and electrical integrity. There's more here on the microbiological, volumetric, and standardized testing as well. From a regulatory perspective, obviously we've talked a bit about the MHRA guidelines. We have to make sure our devices naturally meet all of the requirements for coming to market. 13485 MDD, now MDR compliant. We use BSI as our notified body, amongst others. In terms of the use of remanufactured devices globally as it grows, so does the body of supporting literature, and there's a whole host of papers out there that help support clinical teams when choosing to use remanufactured devices. And there's a recent paper from St George's in London, and their conclusion cites that using remanufactured, in this case catheters, was safe, efficient, and reliable. That's great. That's all the plaudits that we need. This is the portfolio. So we have the main area is electrophysiology catheters, but we have some surgical and devices that we're providing into the UK now. Orthopedic endoscopy device, we do a lot of that on the continent, more of that to come in the UK in the not too distant one hopes. As part of the setup, obviously we do a full opportunity assessment with the hospital. Depending on their level of adoption, you can quite quickly, and the areas that they're working, of course, you can quite quickly get to 6 figures of savings per annum through just taking on a small percentage of their overall supply and turning that into remanufactured. If you'd like to set up collections at hospital, this is the process that we go to. Obviously, what's critical is that we involve all the key stakeholders and we talk through the process with everybody that needs to. We provide all the collection materials, all the training free of charge, and then we continually do that to make sure everybody's kept up to speed with the process. The actual process of collections is not onerous. It's very quick and easy. If you'd like to reuse the catheters or the harmonic scalpels or whichever portfolio you're looking to adopt, the point, obviously, with the key group is to make sure the physicians are on board and versed, and that we have all contractual obligations, etc., in place. That's a vital component. So in summary, there's some numbers here of what we've delivered so far in the UK, and this is for the full year 22. As you can see, there were nearly 3,000 remanufactured devices were used, delivering almost 500,000 worth of estimated savings. We're just getting started, really. So what's next? We're on track to double those metrics, looking for wider adoption in the hospitals across the UK. And obviously, as we go, we're always being asked this, and our job is to try and expand the portfolios of devices that we can remanufacture to avoid them just being unnecessarily thrown away. So I hope that, in a bit of a whistle-stop fashion, delivered on the objective to give you a bit of an insight into what it is we do as a single-use device third-party remanufacturer. Thank you.
Thank you, that was great and really interesting. We have got a question for you here. So how ready for remanufacturing are the NHS and their waste management systems? So I think reflections on that be great, Paul.
Yeah, if basically what we try to do is capture the devices at point of use before they even enter into the waste streams. So in answer to that question, we are actively working with theatres and the cath labs before these devices are even thrown away. So we don't want this to be an additional job for the NHS and the relevant waste teams. We have to capture it before that. Now, further down the line, as this becomes bigger, maybe there'll be some adoptions to do some mining from the waste streams and to do some sort of sorting therein. But at the moment, we do it before it even enters.
Thank you, that's really good. Just from my perspective, I think I was really encouraged by the supply chain resilience part. I'm a pharmacist by background and have spent many times trying to source things from a supply chain that's collapsed. So encouraging to see that there's other options there. Have you found sort of any pushbacks or anything from people like infection prevention teams and that sort of thing, and how have you gone about those?
Yeah, as mentioned on the process, when we're setting up the hospital, it's really important that all the key stakeholders are aware of what we do. And we've set up in 75 hospitals across the UK, and obviously spoken to IPC and they've been versed in all of those. So yeah, they have some initial questions but as it's a new service, it takes a little while for, I guess, for the understanding to really to bed in. But once they understand the process, they see the requirements at the front end, and then that we take ownership of these devices. You know, that once that switches across, and they understand then that it goes off to go through the process, everything becomes CE marked, etc., etc. Yeah, we have some questions, I think, to answer initially, which is natural, but we tend to answer those and then move forwards. So yeah. Yeah, I've just seen that question actually come up. So again, our CE mark is based on proving that this device is robust enough to be able to withstand a certain number of turns as a remanufactured device. So some of the portfolios are twice, and that's some of the theatre portfolio, the surgical harmonic scalpels, for example. But some of the EP catheters can be remanufactured up to 4 times. But each and every time, we have to make sure that device passes its quality check.
That's great. That's excellent. And now we are moving on perfectly in time to Clive Spooner from Vernacare.
Hi everybody, Clive here from Vernacare. My role is I'm the company global training manager. So hopefully you can see my slides. This is a presentation I actually did to the Infection Prevention Society Friday of last week in the special interest group on sustainability. And it's our route to net zero. A little bit about Vernacare. Lots of people know us. We've been around since the Crimean War, when we produced dressings for way back in the day. I think often companies like Vernacare are viewed as a bit of dinosaurs when it comes to changes and things that are happening within the world. Well, we're here to show you a little bit about what we've done at Vernacare. People know Vernacare because we're famed for human waste disposal, infection prevention, clinical waste management, and surgical solutions. But sustainability is at the core of what we do. So our mission statement, sustainability is a vital part of it. Now, my background is infection prevention. Just want to highlight a little bit about the carbon cost of a healthcare acquired infection. This is really important because everything we do is to keep patients and staff safe. So if something goes wrong, someone actually does develop a healthcare acquired infection, there's actually a significant carbon cost related to that. Along the lines of it's 37.9 kilograms of CO2 per patient per night in a hospital bed. That actually increases to 100 kilograms of CO2 per patient per night. So prevention is really important. We need to be stopping patients having prolonged stays within the healthcare facility. So the benefits of single use. Now, there's a lot of narrative at the moment, and we're seeing about the fact that, oh, we should be reusing, we need to reuse, but single use actually does have a big benefit. The most important one amongst these is eliminating the risk of cross-infection. It's so vital that we actually do keep our patients safe. There's fantastic work taking place whereby I can see what Paul and Andrew are talking about. Absolutely brilliant, absolutely wonderful. But sometimes, in some areas, are things being effectively decontaminated? Are we reusing things that we really are putting patients at risk? Now, key thing I think I know from Paul's presentation, I know the business well, they actually do guarantee full certificate and they produce evidence of validation of decontamination. But some things we're now reusing don't. It's just the manufacturer saying, yep, guarantee they're clean. So we've really got to be very, very careful with this narrative about reusable. Now, but single use isn't very sustainable, I hear you shout. What I'd actually like to do now is just go through a little bit about what Vernacare are doing and how we are being a very responsible, sustainable UK manufacturer. We have 4 sites: Bolton, Chorley, Blackwood in South Wales, and Worksop. And all of our businesses are being run in a sustainable manner. Back in 1964, we actually pioneered a human waste disposal system whereby we used a byproduct of the paper industry to move people away from reusable urinals and bedpans to single use. We actually picked all sorts of environmental awards, and we still do, for the way that actually is done. It's a byproduct of the paper industry. We're not using a virgin raw material. It's already a byproduct of the paper industry. We're the UK's last manufacturer of cotton wool in our workshop facility. We don't use virgin cotton to make cotton wool. The cotton wool you actually see in Tesco's and Super Savers, and it's actually manufactured by Vernacare. And it's all manufactured in the UK from a waste product from the cotton fashion industry. In Blackwood in South Wales, we actually manufacture Sharp Safe, Clean Safe. Plastic sharp spins? Oh, no one wants plastic anymore. Well, in actual fact, bases are made of 100% renewable recycled material. So we're actually working very, very hard to actually ensure we never use virgin materials in our manufacturing process. So a little bit now about the scientific side, our carbon reduction targets. Well, to allow Vernacare to target and identify areas for improvement, we've calculated a full baseline emissions report for financial year 2022, which includes scope 1, 2, and 3. And following GH3 protocol guidance, 12 of the 15 GH protocols subsections have been calculated, with the other 3 not being applicable to Vernacare and our operations. Now we're targeting a further 19.7 reduction in our carbon emissions by financial year 26, using financial year 2022 as a baseline. So our carbon reduction plan is live on the website and demonstrates our plans to reducing absolute emissions. The most important thing for all manufacturers is energy. And that's the other thing I think we all have to be very conscious of. What are we actually doing to make sure we're actually using renewable energies during all of our processes? We don't offset at Vernacare. That's a cheating way, in our opinion. It's too easy to turn around and say, oh, we've offset, we planted 500,000 trees somewhere in the world that you'll never get to see. Offsetting is a con. It's greenwashing. Avoid it. Any company that turns around and said they're offsetting means they're admitting they've got a problem. They're not actually doing anything about it. You really have to start to analyze people's carbon reduction plans to actually see if that word offsetting is actually in there. So this is what we've done. Now, at Vernacare, it's not just about green wishing. We're not turning around and saying, oh, this is what we're going to do, and on December the 31st, 2045, we're going to do it. No, no, no. We've actually been active over the last 2 years. Those items in dark green, we've already achieved. It's the items in light green are what part of our next 3-year scope. And that's the important thing. We've already done a lot of things, but we're already a sustainable manufacturer because we're already upcycling and reusing materials during our manufacturing process. We're not just doing it alone, and that's the important thing. It's not just Vernacare turning and saying, oh, aren't we good? No, we actually have worked with academia. All of our evidential support is backed by Rap Cymru, Bangor University and Cardiff University. Hence the reason when we moved over for our sharps containers, we moved away from virgin plastic. We haven't turned around and said, oh, we use 10% less, 20% less. We use 100% virgin materials in our base. It does mean they're now black, grey. They're not yellow anymore. But this is part of the responsibility all of us have to actually have as we go forward. So whether people are in procurement, whether they're clinical, yeah, we're going to see slight changes in things. Behind me here, I've got one of our 1.8 litres. You can see base is grey. As per HTMO 701 and SHTN 3, we actually do adhere to clinical waste protocols. But we're doing an awful lot. The other thing, we're being recognised. We're an EcoVadis bronze level manufacturer. We recently recognised by GHP as the most sustainable manufacturer in infection prevention. The big one for me is the fact we're a bronze level carbon literate organisation. Because all of us on these calls at the moment, it's great we're seeing things that are being done by manufacturers. I'm passionate about sustainability, and I really appreciate Pete and Anna allowing me the opportunity to actually speak to you today. But I ask this question of everybody on this call: do you know your personal carbon footprint? Have you been onto websites like Geeky Zero, where you can check your own personal footprint? Because it's not just down to manufacturer, it's not just down to industry to be changing and making sure we do hit net zero emissions as a nation. It's down to us individually. If you check and you go on and you have a look and see what your actual output is, the challenge to all of us, regardless of what we're doing within business, is to reduce our personal footprint by 10 to 15%. If we all achieve that, we give the world a fighting chance. Now, forget 2045. That's a long way away. 2030 is the key. We already have to accept the Earth is going to warm to 1.2 degrees by 2030. We need to all together work together to make sure it doesn't go above 1.5 degrees. If it goes above 1.5 degrees by 2030, then we have a humanitarian and global crisis far bigger than we do at the moment. Thank you so very much for this opportunity to present to you. As I say, my name is Clive Spooner, and I'm happy to take any questions.
Thanks, Clive. I think you set a real challenge to us all at the end there, and I think something that we're all quite conscious of, or I hope we are, because we are here today. But that actually we can all go and look and take some steps in action now, but also that it is a climate and humanitarian crisis that is creeping up quicker than we would like it to. Any questions for Clive from there?
Tends to be, because being single use, we're often viewed as the bad boys. Oh no, they're a single use manufacturer. And it was a wonderful discussion we had at the Infection Prevention Society last week, whereby, oh no, you're good guys, you're good guys. And you're saying, yeah, but don't tarnish everybody with the same brush. You know, Vernacare, we're a very sustainable manufacturer because we don't use virgin materials in our manufacturing processes. But like I say, the biggest thing for all of us, it's great that we're actually here today and we're talking about this. But unless we actually do things in our personal lives as well, it could be simple things. It could be moving over to a renewable energy provider like Octopus. Doesn't cost you any more money, but you're actually getting all of your power supplied from a renewable source that's been put into the system. Starting to look at how we travel, you know, public transport. Hopefully it be a little bit more reliable in the near future. But yeah, are you jumping on planes? When you're going away on holiday, how are we traveling? When products are being manufactured from overseas, how are they being brought into the country? You know, when we're doing things like recycling, upcycling, hopefully all these guys that are on this call are actually using renewable energy during their processes and are trying to reclaim as much of the water and that they're actually using, because these are the things we need to be doing to give this Earth a fighting chance.
Thank you. And I know, I think, as you said, there are sort of some instances where we do need to use single-use items, and obviously Vernacare offers some solutions in some of those areas. So that's very interesting, and gained quite a lot. I know we've learned quite a few. I don't know if you could just you talked about sort of some of the products that you had. I know you talked about the sharp spins, you talked about the cotton wool. Just give us a little bit of a flavour of those infection prevention type
you
items that you have.
You tend to, into any healthcare settings, you tend to never be more than 15 meters away from a Vernacare product. So Vernacare, we actually manufacture all the human waste disposal products. So all the papier-mâché bedpans and urinals and wash bowls, all of those you see in hospitals, we manufacture those. We also manufacture the sustainable disposal system that's in a dirty utility in a sluice room for disposing of all of those items down to fully biodegradable, down into the drainage system, and within 20 days, no effect. They've gone fully biodegradable. That's where the actual biodegradability, you don't actually have any evidence of what goes down from Vernacare down the drain. Sharp spins, we do a full range, sharp safe and clean safe, full range of sharps and clinical waste disposers. And also we do an awful lot of wipes, but plastic-free wipes. You know, we need to be moving forward with wipes, and with the patient wipes, we don't want plastic in things anymore. But I'll put the link to the Vernacare website so anyone can see what we do.
Very quickly as well, just one question. Thanks, Clive. Your passion for the subjects of infection. One question. Your S3 looked low by comparison with many companies. I don't know if you've got a quick answer there, or you're able to just. I have put that into the Q&A, so if you would be able to just nip into the Q&A, that would be great and answer that.
Yeah.
Thank you.
3. We need the NHS supply chain to get busy, because we can't affect the scope 3 on our distribution, because we deliver to them and it then goes from them to Grave. We need the NHS supply chain to be far more sustainable and effective in their logistics and distribution. That's the answer to scope 3.
Lovely, thanks, Clive. And we will just move on to our next presenter now. So project plan B, and we have Tim Cross. Is Tim here?
I am. Hello.
Hello, welcome. I'll let you go.
Thank you very much. It's a pleasure to be here. I'm just going to hopefully click here, and we should be. Let me know if that's all coming through at your end.
That's perfect. Thank you.
Cool. Good afternoon, everybody. So my name's Tim Cross. I'm from a company called Project Plan B. So I've been in the manufacture and design of clothing and uniform for the last 25, 30 years, looking at how we can supply clothing at large volumes to large employment requirements. So supermarkets and the NHS being good examples of the kind of thing that we did. Over the last 5 years, we tried to understand what we could do to try and improve our carbon footprint and try and see how we can improve our offering. And it was very clear to us that we were making an oil-based product with a very high carbon footprint, and we weren't actually able to recycle anything that we were making. So we started off on a journey to understand why it was that you can't recycle clothing, and why clothing, in particular uniform, wasn't recyclable. It boiled down to clothing's not designed to be recycled. And why is clothing not designed to be recycled? Well, because there aren't any recycling facilities to recycle the clothing in anyway. So if we set about designing clothing to be recycled, we would also have to build a recycling system capable of recycling that clothing as well. So that's exactly what we did. And we built a machine which is coming to the UK in about 3 weeks' time. It is the first of its type in Europe, and it is capable of recycling polyester clothing. And this machine has got an inbuilt shredder, and under heat and pressure, it squashes and squeezes and crunches up and turns the clothing through some very clever filters and produces pellets. And these pellets are the building blocks of all plastic clothing and all plastic items, so we can reuse it all over again. And so I've got some pictures here of the machine in use. So you can see on the top left-hand side there, clothing going up a conveyor belt. It then gets chopped up in the shredder, dropped down into a load of high-tech kit, and pushed out as pellets, which we then hope to spin back into yarn. And we think that this is the future of all clothing, and the way that all clothing should be made going forward. It doesn't have to be polyester, but it does need to be designed to be recycled. And if you design clothing to be recycled, it stands a chance of being recycled. The clothing that we are working with is 100% polyester. the better the feedstock going in, the better the feedstock coming out. So if we put clothing that is designed to be recycled into the system, we will be able to recycle it and get a spinnable yarn coming back out the other side. So we've been able to do this with good success, and we've got different grades. So we're trying to understand that actually not everything is going to be perfect first time. So we can also make injection moldable plastics, which is a much higher tolerance on it. So we can make buttons and buckles and coat hangers and all kinds of things from the polyester pellets that we produce. So why does it work? Why is it that after years of being told that you can't recycle clothing, why have we been able to make this dramatic breakthrough in the way that clothing is recycled? And the fundamental reason is design. If you just think that you can carry on making clothing and wearing clothing in exactly the same way as we have done for the last 30, 40 years, we are very much mistaken. All of this is going to change. We are going to now start having clothing that is designed to be recycled. It's designed to be circular. We don't really have a huge amount of choice about it because legislation is going to force it that way. So if you are thinking about uniform projects at the moment, you have to think of the long term. In 2025, our clothing in Europe will need to come under EPR legislation. So extended producer responsibility legislation. So you're going to need to design that circularity into it. Otherwise, it's going to become expensive and costly. If we can design clothing that is recyclable, our understanding or our belief is that actually what we'll end up doing is creating a system of clothing that is in a closed loop. And what better way of doing closed loop clothing than uniforms and scrub sets, because you know where that clothing is all the time, particularly if it's in a laundry system. As the garments are used and worn, and they're not, we never want to speed up this process. We're very happy for it to take as much time as it needs to. It passes through the use phase. It then gets checked by the laundry. Is it capable of being worn again? Once it's reached a point where it's no longer capable of being worn again, it can be pushed into the recycling system and returned back to us, and we can recycle it back into pellets and push it back into the clothing system. So we make clothing which is 100% made out of recycled materials, 100% made out of recyclable materials, and it's designed to be recycled. And this produces a significant carbon saving, about 2,000 kilos of CO2 per ton of clothing. So worth having. The pellets that we make are the building blocks of all plastics, all polyester plastics. They have about 11% of the energy requirement of virgin. So that's a massive saving. By recycling the clothing, we are saving a huge amount of carbon. Just to run you through a relatively simple idea. So on a trust or of an area that's got maybe say 150,000 members of staff, they might have about 1.2 million garments in circulation within that at any one time, which is about 400 tons of polyester. The only route out for that polyester at the moment is for it to be incinerated. So that's 404 tons of CO2 just in burning that uniform and those scrub sets. If you then were able to recycle it, that's 2,240 tons of CO2 saved. 2,240 tons from 150,000 piece of uniform contract. It is a massive saving, and we'd highly recommend that people look at this as a way of massively reducing their carbon footprint. If you then chose to carbon cost that, well, on that 150,000 employees basis, we reckon that works out at about £156,000 of carbon credit saved, which works out at about 388 pounds per ton, about 13 pence per garment. So a significant cost saving by reducing down your carbon footprint. All of this is verified by the UAL researchers who did the work for us, and very clever people at RAP who verified and checked all of our working. So yeah, a really exciting thing that we've been working with there. I'm just going to finish my bit with this quote from Ellen MacArthur. Global economy is not a force of nature. It's made of a million decisions. It is designed and it can be redesigned. It's within our gift to make these changes, and we can do a fantastic job as a result of that. So that's my very, very brief presentation. Are there any questions? Have we got time for questions?
So we have got questions. So I think a comment that I would just like to highlight, because I think it's brilliant, is this should be in Fashion Declare's London Fashion Week conference today. So I think there's definitely room for this. I think not just in healthcare. But we do have a question here. Tim, how many times can the uniforms be recycled before the material quality falls?
Okay, it's a very common question. It's a very useful question as well. Whenever garments are recycled, they are then pushed back through the same process to bring them back up to the same quality you can make good yarn out of. So it doesn't really matter how many times that garment has been recycled. You will always bring it back up to the right level that you need to make new yarn. But also, if you think about it, the chances of you knowing how many times a garment has been recycled is almost impossible, because it will, if you make 100,000 garments and put them into the system, you're not going to get them all back on the same day, recycle them all on the same day, make new garments out of them all on the same day, and put them back out to the same position and use them all over again and bring them back in. They all get mixed up, and there'll be some new ones, some young ones, some old ones, and it will all be mixed up again. It's down to the yarn manufacturer to then make sure that the quality of the yarn hits the targets they want. And you can, the great thing about polyester, it's a long chain polymer, you can always improve it, you can always make it better.
Thank you. That is really good. I guess one of the questions I had, and I may have missed it, so I apologise, but is it just for sort of all in one garment? How do you deal with zips or anything like that? How does that work?
There are lots of solutions available. So you can get polyester zips, which have got polyester teeth and polyester tape on them. You can even get polyester sliders and zip pullers. We're actually recommending using metal sliders because they don't wear out so quickly and they're very easy to detect and cut out at the last minute. So yeah, there are lots of solutions to that. And yes, please do speak to me about any of the other challenges that are out there. But we've solved pretty much all of them.
Great, thank you. Any further questions from anyone? I guess then I'll just pose for sort of a few minutes until we've got our last speaker of this session. Anything in particular that sort of an ask from you, any particular things that might be of use for us or for healthcare people to input into?
I think the opportunities for the healthcare world to look at circularity within their uniform requirement, and Tom, who's going to be speaking after me, is going to pick up on all of this. And it's just, the opportunities are massive, and we have to change the way that we're doing things. The way that uniform is worn and used at the moment is far too linear. We cannot continue to go at this pace with 700,000 nurses wearing scrub sets or similar uniform at the moment that's not recyclable. That's thousands of tons of CO2 that has been wasted. And there's a really simple opportunity to transition into the circular economy just by swapping those things around. There won't be a cost increase. There will be a longevity increase. It will last longer. It will perform better. It will be a much better product to wear. And we just need to transition away from where we are to something new and something better. And we've done this with, everything else in our world. We've got rid of plastic bags at the supermarket, and we've got rid of the idea that you should constantly be buying plastic water bottles. We can make transition, we can make these changes, and just look at the opportunities ahead of us. And get in touch, speak to us about it, and we will help you transition away from single-use clothing.
And we have got a couple of questions here. Sorry, Sam, I managed to, sometimes that doesn't come up in the Q&A. Do you want to talk, or would you like me to ask those questions? You're welcome to come on camera if you'd like to talk, Sam. You can do it. Okay, so will this system work with polycotton products?
No, polycotton at the moment is unrecyclable. So you need to transition either into monofiber cotton or monofiber polyester. And polyester is a much, much better product for circularity, particularly in uniform, because it maintains its color, and it is a much easier product to wash and wear. It doesn't require so much energy to dry, etc. There may be recycling facilities in the future that can recycle polycotton, but they will specialize in either recovering the polyester or the cotton. Unlikely to be both.
Thank you. And then another one as well from Sam is, are the new scrub suits 100% polyester? How have NHS staff responded to having a fully polyester scrub? What would be the cost of a scrub compared to the current polycotton market prices?
Okay, I'll leave the costs out because it depends entirely on volume, and you'll have to speak to the clever people who will help you out with that. But there's absolutely no reason for it to cost any more. Because polyester is actually cheaper than polycotton. So you should be able to purchase better going down this route. But with regards to how you wear, make sure that you're using a polyester that has moisture moving facilities. So you move and people complain about polyester being sweaty. There's absolutely no reason for it to be so. It needs to move the moisture away from the skin to the surface. If it does that, it spreads out, evaporates, the moisture will end up cooling you down so you don't get hot and sweaty. So there's absolutely, again, no reason why you should have this sense that it's hot and sweaty. It is much more to do with the fiber choice that makes the moisture move from one side of the fabric to the other side of the fabric.
That's lovely. Very quickly, Tim, if you would be able to just pop into the Q&A section, and if you could just sort of outline a bit further. I've tried to capture some things, but not as eloquently as you're able to do so. And we will move to Tom Dawson, so from Revolution Zero, and I will hand over to you, Tom. Thank you.
Thanks very much.
Yeah. Hi all, and yeah, and nice to hear you present, Tim. Sorry I didn't get at the end. I was on the way down the A30, so you were going to have a red bus behind me, but it was like too noisy out there. So, and thanks as well, Anna. I'll talk about some of our work that we've been doing, and I'm just coming back from Cornwall at the moment, where we have our on the ground pod you can see here in the background, and they were just talking today about how they do not like their polycotton scrubs because when fluid gets flung across the theatre, they get soaked. And I said, well, you can go for a polyester. So your words there, Tim. And great to hear you speak. So yeah, I'm a clinician originally trained in emergency medicine, and also have a doctorate in physiology. And I founded Revolution Zero back in May 2020. I'm just going to go through the story that we've gone through. So the problem we're addressing, you're familiar, and Tim touched on a lot of this now, but was 30 years of healthcare waste transition really from reusables to single use over those years. And it was again a transition away from cotton, which it needed to be, but it came to single use. We found in the pandemic that the actual supply chain, the global just-in-time ultra-convenient supply chain, is really vulnerable. It also can be unnecessarily expensive, and it can be variable quality. The other issue we're also addressing relates to net zero challenges. To give you an idea of the issues that we're looking at, we specialise in surgical drapes, so that's drapes used in operating theatres and surgeons' gowns. It's our specialty. There's more than 53,000 tonnes of these particular regulated medical textiles wasted every year. They're incinerated. That's the equivalent of lining 10-tonne lorries all the way from the centre of Oxford down the M40 to the centre of London. So that's it, and that's not including the packaging. So to address this, we came up with a mission statement, which is to displace single-use medical textiles with reusable alternatives that are more effective, economic and sustainable. Tim's just talked about circular economy. We're all about circularity. That's preservation of resources, preservation of energy, and also preservation of information. So we do this through technology-enabled solutions. Preservation of information is a know-how that you may take to run, for instance, a healthcare laundry. You digitize that, you take that training, you take that knowledge, and you can then port it and transfer it and make it scalable. Preservation of the compliance systems. So we closely co-design our medical textiles with clinicians, and I've just been in a co-design meeting today where we were looking at transfer sheets, and we were also looking at specialist knee drapes for various knee surgeries. One of the other things we specialise in is the development, and we've developed a rapidly scalable modular processing capability. So rather than taking several years to build with lots of concrete and bricks and so forth, we can build off-site in around 3 months using a lot more sustainable materials, and they are long-lasting, guaranteed for 25 years, built for a century. And everything we do has a net zero focus. We've got wonderful teams and supporters and stakeholders behind us, and great university partners. I'm also a visiting research fellow in circular healthcare at the University of Exeter, so that's it's really nice to have that strong academic association with them, and also UCL, University of Southampton, Nottingham Trent University as well, who do a lot of our repurposing. So for instance, a surgical gown can get turned into an endoscopy gown, can then get turned into a patient gown. So keeping that circular thing, and then send them across to Tim for the recycling. So as I mentioned, we were founded in 2020. Really our focus is on enabling the enablers of making this all happen. So really that's around the medical textiles and infrastructure. So digital technologies, physical builds. We've had a rapid capability growth. 2.5 years ago, it was me on the kitchen table. We've now got 30 in the team. So it's really been a staggering growth curve. Active local and international engagement. We've been supplying to Medicine Sans Frontières out of Mozambique and Kyrgyzstan, in Denmark next week, to look at being a development partner with the Danish healthcare authority. So we've continued to work here. You can see some pictures of our co-development work with the surgical teams. So what value do we offer, and what value do we offer the not only the NHS but the nation? So we have a rapidly scalable physical and digital infrastructure which provides the secure supply of business critical products. So we talk to procurement people, and almost every week there is an issue with something in the supply chain not being effective, not being able to be, accessed, generally effective, but not being able to be accessed. There has been a weaponizing of many critical supplies. There's geopolitical conflicts, there's all sorts of stuff going on. They are challenging times. We also provide a higher quality, more effective product, which is preferred by clinical teams. If something's going to be used 75 times, you can put more investment into it. If you spend an extra 50p on it, it costs less than a penny per time, especially if you're talking about surgical operating theatres. The cost for hip replacement surgery, for instance, in the NHS is around £6,000. The cost for all the textiles for that is around £40. So yeah, it's not much cost compared to what we're putting out for there. So overall, as well, we are generally lower cost. We give carbon savings, and also the prevention of waste is the other value points. Talk a little about NHS Cornwall Hospitals Trust. I think I'm just inside Cornwall at the moment, so still there, just about to cross into Devon. But we started with them with the NHS reusable masks project, which was actually all across the NHS, led by Alexis Percival with the Yorkshire Ambulance Trust. From there, we deployed the world's first Type 2R at scale masks, which were reusable in a clinical hospital environment. We then went through to integrate digital systems, so we could monitor the use, but also we've developed a system we can actually monitor the carbon savings, monitor the waste savings and the water savings, and that we updated that again last week, so it's now online in real time. We transitioned quickly into other things apart from masks, so aprons, gowns, drapes, high-risk gowns, and we've even replaced the packaging as well. So we use a reusable sterile packaging system, which we continue to develop. We're now rolling out in Cornwall. We have our pod on the ground. It has been delivered to more than 10 orthopaedic surgical teams, the birthplace of single-use medical textiles, which is hip and knee joint replacement surgery, so large joint replacement surgery, and it's been taken up really well. Wonderful feedback. In fact, it's been amazing feedback. It's been really good. So the NHS Cornwall Hospitals Trust, we're modelling that for scaling up. We're replacing around £500,000 of product plus £200,000 of waste cost across the piece. We have built and designed scale-up models. So for instance, for a 10 elective mixed operating theatre. Within 4 months, we can have on the ground and operational, and then building up over time model savings of £83,000 and 222 tonnes of CO2 in a year. And you can see here some. This isn't a person. This is our co-development work. This is actually in theatre at the time, and this is some of our waste audit we're doing. We save around 3 kilograms of waste per hip replacement operation. Now, hopefully, this will work. So yeah, so this is now pod in yeah, sorry, the obviously the soundtrack didn't come through, but this is now pod in Cornwall, and just a short video showing how that worked. It was just a soundtrack on the. I'll just try and progress that. So when the NHS are notoriously difficult to have an uptake thing. So we have a specific ask when we go to them, and we really ask for action focused engagement. We're not interested in pilots. We think they're an extinction event for any small company going forward. So we actually action focused engagement. We like to bring together clinical, finance and procurement teams, and also we like to focus on economic, environment and social gains with the added improvement experiences for clinical teams and inbuilt resilience in these conversations, and continue them to see where we can go, because we can work with ongoing supplies, ongoing essentially cost streams, etc. So the future for us really is we're ready to implement and deploy circular healthcare solutions now. We have a unique team, and I haven't gone into detail on the team due to time, but we have just considerable flexibility in how we work in partnership with the NHS and also actually other suppliers. And so I just mentioned 3D printing, and it'd be good to talk about that. And we have looked at different 3D printing models to help with some of our stuff, especially from post recycling. But we look at different models to suit different innovation, sustainability, and resilient experts. So thank you very much. I'll stop there. We've got a whole lot of stuff. That's our general model there, but I'll stop there and open it up for questions.
Thanks, Tom. That was really interesting. I don't know whether you want to leave that slide up potentially, just in case we've not got questions and you do want to talk through it. There's not questions in the chat at the moment, and I'm just checking the Q&A, but nothing there just at the moment. So if you've got a little bit more you wanted to talk through, but if anyone does have anything for the chat, hands up or pop it in, and I can interrupt or whichever. But if you've not anything just yet. Yeah.
Certainly. So I can talk through this circularity model. So this was sketched down when we sort of had the initial thing of going, well, wouldn't it be nice to have a system which had zero waste and zero carbon, and moving that through. We wouldn't actually say that now because that could be considered sort of a greenwashing, making any claim like that, or even if it's a target. So we don't want to infer anything like that. But we really work on trying to. This is really the basis of our circularity. So looking at the reuse model here, where we're looking at reusing multiple times, how can we make that more efficient? Really, some of the work that we've done under that, we've had 2 healthcare SBRIs. First one was to get this Cornwall up and going. The other one was to decrease the temperature of decontamination, and actually by shifting over to renewable energy makes massive carbon savings. Now the biggest carbon cost in our facility is actually the supply and the extraction of water, followed by the chemicals, and then the electricity after that, or power after that, by switching to renewable sources. We really focus again on local manufacturing, reprocessing, recycling, so giving stuff back to local communities. And that's really important, and it's important for the resilience as well, and the buy-in. It's nice to have sort of a local community culture and actually see how we can do that. And our future plans are to take this model all over the world and go through there. We're actually having a conversation with a food processing company in Ghana, and they are horrified by the amount of waste. So we're doing it for no charge, which is sort of under our so we're not not charging them anything for our advice and how they would set up a process, but which they can actually, again, looking at things like polyester materials, how they can use local manufacturers, how they would design it, how they would specify it out, what they would do to keep things safe and everything like that. So it's really one of our dreams is to expand this globally and help local places, and especially the lower and middle income countries, which are so impacted by the climate change, which we all created. So that's it's probably enough to say for now. I'm sure I can go for hours, Anna, so don't let me. So
it's all right. It's really encouraging and seeing the and I think it's coming through in quite a lot of the presentations. The sort of the social value, the other benefits of a lot of these sort of innovations and things that we're doing, and it's not actually just about, it's about the bigger picture, isn't it? And trying to make the planet a better place for all of us. Which I think is really good.
As I said to my my 7-year-old now, when she was 5, and she said, "Daddy, I know you're a doctor and I know you work with the NHS and you do stuff with masks. What do you do?" And I thought, well, how do I explain sustainable medical technologies to a 5-year-old at the time? And I said, well, I'm part of a team, and you know how the polar bears are dying and the ice caps are melting, because she was into that. And she said, yeah. And I said, well, we're part of a team trying to stop that. We're a part of a team and a community trying to save the world. And then she said, "Oh, you're trying to save the world, Daddy?" I said, "Yes, I am, with a lot of others." She said, "Daddy, you're a superhero." I said, "No, Mummy's a superhero. I'm just part of a team trying to save the world." So it's very nice when you change your perception to, it helps you really bounce out of bed in the morning when you actually go, I'm not a sustainable medical technologist, I'm actually trying to save the world. It's very different feeling going forwards, and it's a very different driver, and it's important. And I know Tim feels the same way about that as well. And also Paul, who I've seen in the chat here as well. Yeah, it's good.
Yeah. Thank you. That was absolutely brilliant. So we're right on 2:30. Again, please, if you do want to connect with anybody,